Hello, everyone. This is Bert Dixon. Today we're going to be working on section 14.1 in your Algebra 2 book. And we're going to look first at how you can tell from data if a function might be exponential or not. And then we're going to look at using technology, your graphing calculator in particular, to come up with a exponential curve that does a good job of fitting a bunch of real life data. Okay, so first let's take a look at how we can tell when a function is exponential or not. So if we look at example A here, we have a bunch of x values and y values in the table. And so what we're going to do is we're going to look at the consecutive quotients of the y values and see if they are consistent. And so f of 1, for example, is 4, and f of 0 is 1. So we have 4 divided by 1. That quotient is equal to 4. f of 2 is 16, divided by the y value that came before it, which is 4. That's also 4. f of 3 is 64, divided by the y value that came before it, 16. And then the next one is 256 divided by 64. Both of those are also 4 as well. So the quotient is constant. It's 4 all the way across the table. And so that suggests when that quotient is the same or very close to the same, that suggests that our data is exponential. Okay, so now let's take a look at B. So if we look at the quotient of f of 1 to the y value before it, 7 divided by 1, that's 7. And then we have 13 divided by 7. That is not 7 for sure. Let's see what that is. So 13 divided by 7 is about 1.86. I'll write it up on top, 1.86. And then f of 3 divided by f of 2, that would be 19 divided by 13. 19 divided by 13 is about 1.46. And then f of 4 divided by f of 3, that's 25 divided by 19. And that is about 1.32. So definitely not the same all the way across. These fractions are not equal. They're actually decreasing, and they're not even close to being the same as each other. And so we can say that this data is not exponential. So for the first one, you'd say the data are exponential because the quotient of consecutive y values remains constant. In this one, the data are not exponential because the quotients are not the same. Okay, so I'd like you to go ahead and try part C. Look at the data in this table, look at the quotients, the consecutive quotients of the y values, and decide if they are exponential data or not. So pause your video, and when you're all done, press play to check your answer. So the first one is 4. The second one is 13/4, so we can tell already they're looking like they're not the same. 28/13 and 7/4. Those values are not anywhere close to one another, so the data are not exponential. Okay, so then go ahead and try part D as well. Pause your video and determine whether or not the data are exponential. So here we have, if you do 0.25 divided by 1, that's 0.25. So I'll write it up above, 0.25. and then we have 0.0625 divided by 0.25, that is also 0.25, and then this one is also 0.25, and this one is also 0.25 when you do the quotient of this divided by this. And so we get the same quotient all the way across, 0.25 or 1/4, and so we can say the data are exponential. Okay, next we're going to look at finding an equation to fit real-life data. So let's take a look at, we're going to look at example 1a, but we're not going to use their method here, so you can ignore the process they're showing. We're going to use the calculator to come up with the curve, the exponential curve that fits that data. And so if we look at the graph that they have here, that what they used for their x coordinates or the decades since 1970. So a decade is 10 years. So this would count as, let's see, it says since 1790, rather. So this would count as x equals 0 because it's 0 decades past 1790. This is 1 decade, 2 decades, 3, 4, 5, 6, 7, 8, 9, and 10 decades after 1970. And then the y values we're doing in millions. And so we would call this 3.9, 5.3, 7.2, 9.6, 12 point, let's call it 12.86. We can actually use more decimals here, so we can call this one 3.93, 5.31, 7.24, 9.64, 17.06, 23.19, 31.44, 38.56, 50.19, and 62.98. And so we're going to use these as our x values and these as our y values, and come up with an equation to give us our exponential curve that does a good job of fitting the data. Okay, you're going to need your graphing calculator for this, and I'll go through step by step on how to come up with that curve of best fit. Okay, so the first step is to go to the stat menu. You can see the last button I pushed on the calculator is in red, so I went to stat, and then we're going to use the edit menu, so that's the first option, so just press enter. And your list 1 and list 2 might already have data in them. So for example, if I had data already in this list, just as an example, if I wanted to clear that data out, these are the steps to clear your data. So if you have anything at all on list 1 and list 2, this is the process. Go up and highlight the title, and do not press delete. That'll delete the entire list. We want to press clear. So clear, enter, clears that list. Do the same thing with list 2. Highlight the title, clear, enter, and that'll clear the data. Never press delete, because that will delete the entire list, and then we'll have to go through a process to get those lists back again. Okay, so we're going to use list 1 for our x values. So looking back over here, we have our x values, and so we're going to type those in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and then in list 2, we're going to type our corresponding y values, 3.93, 5.31, and so on. So go ahead and populate your lists, list 1 and list 2. Okay, so I have my lists populated. If you're still working on that, just pause your video and press play once you have all of your correct data in the table, as I have displayed on my calculator here. Okay, the next step is to come up with the regression equation. Back in Algebra 1, you probably did some linear regression where you found the line of best fit. Now we're trying to find the exponential curve of best fit, and the steps are really the same. If you remember how you did that back in Algebra 1, the steps are the same, but in case you forgot, here are the steps. So we start by going back to the Stat menu, so I'm going to press the Stat button. And this time I'm going to use the right arrow to go over to Calc. And we're looking for exponential regression. So there's a bunch of different types of regression. That's linear regression, quadratic regression, cubic regression, quartic regression. We're looking for this one, exponential regression, which is at item 0. So you can jump there more quickly next time by just pressing the 0, and it'll jump directly to the exponential regression. Okay, now at this step, your calculator may look a little bit different than mine. If yours looks like this, then you can follow these steps. If your calculator looks a little bit different, I'll go through those steps as well. And so list 1, so our x's are in list 1, our y's are in list 2. So I'm going to accept both of those. The frequency list we don't need. Now this step here, the storing the regression equation, is pretty important because this will help us with entering the regression equation into our calculator in the y equals menu automatically. So we want to store the regression equation as y1. So we're going to go to variables, which is the vars button, y variables, function, y1. Okay, and I'll explain again what that's really doing, but we do want y1 there. Okay, so the steps again for that were variables, y variables, function, y1. Okay, and then we're ready to calculate. So I'll press enter to calculate, and it gives me my regression equation in the form y equals a times b to the x. And it says a is about 4.12 and b is about 1.32. Okay, so that is our regression equation that we can write down. So again, a is about 4.11. So our regression equation is y equals 4.11 times b, which was about 1.32 to the x power. Okay. So next I'm going to show you, if you have an older version of a calculator or you don't have the new operating system, I'll show you, it looks a little bit different on your screen. You should get the same answer in the end, but if you have an older style of calculator, then you'll want to follow the steps. I'm going to basically repeat what I just did, but for the older version of the calculator. So this time I'll demonstrate how you can do this exponential regression or any type of regression really on one of the older model calculators. This is a TI-83. Some of the TI-84s also will look just like this. So I put in all the same data that we did from this table, and then the process is the same to start with. I go to Stat, Calc, and then I look for exponential regression, and it's also option 0 on these older calculators. So there's exponential regression. And when I press enter, here's where it looks different. Remember on the TI-84, it looked like this. When I went to Stat, Calc, option 0, it looked like this. So on the TI-83, it looks just like this. If I press enter, it runs the regression, but it didn't give us a chance to input anything. So it's good for you to understand that when you just choose regression, it's automatically going to take your data from list 1 and list 2. Notice that we got the same exact answer. A is 4.11, which we see here is what we got before using the newer calculator, and B is about 1.32, which is what we had here. So we're getting the same exact answer on the calculator. One big difference, though, on these older calculators is it did not put anything into y1, so I would have to type this in manually, 4.11 times 1.32 raised to the x, which is fine. This one's not too hard to type in because there's not very many numbers involved, but it's also not as accurate as if we had done all the decimal places. So even though this would work, I'll show you how you can actually get it to go in automatically. So when I go back to the stat menu and go to calc, if I go down to exponential regression again, this time, instead of pressing enter, I'm going to do parentheses, and I'm going to tell it to get the data from list 1 and list 2, so second L1, comma, second L2, comma, and now the third parameter is where do you want to put the regression equation? And we'll go to variables, y variables, function, y1, and then close the parentheses and press enter. And so now it's forcing it to take its data from list 1 and list 2 or whatever. If I happen to use 2 other lists, I could type those list names in, and it's going to dump the regression equation into y1. So watch what happens when I press enter. I get the same exact answers, but now when I go to y equals, notice that that whole big equation is already entered for me. So learning how to do the to put y1 in as the regression equation saves you from having to type this whole equation in. Okay, so I'll go through those steps one more time. It was stat, calc, option 0, parentheses, list 1, comma, list 2, comma, and then y1 is under variables, y variables, function, y1. And then close the parentheses, press enter, and it will give you the same answer as if you didn't put in any parameters at all, but it will put the regression equation into y1 for you so that if you want to graph it, you can set up your window and graph it. So the rest of the steps are just like on the newer operating systems, but they have the same functionality. It just looks a little different the way that you enter it all in. Once you have the exponential regression equation, we can view the data that we typed in along with the regression curve to see how it looks. So first, let's set up our window. Looking at the data, our x values range from 0 to 10. So I'll say 0 to maybe 12 so we can see all of them. Or actually, I can even go negative, let's go -5 up to 15. That'll give us a good view. And then the y values, looking at our table, go from 3.93 up to 62.98. So I'm going to go from 0 to 70 for y. And then we press graph, that graphs the curve. And the reason how I knew what curve to graph is because remember that step when we said store regression equation as y1. So you see our regression equation is right here in y1 with all those decimal places. So this is a great way to do it because it's a lot more accurate than if you typed in those numbers yourself. And so there is the whole regression equation. I'll clear out this second equation. That was from a different problem. But that gives us the graph. Now we just need to be able to see the data. And so I'll go to second stat plot. And plot 1 right now is off, so I'm going to turn that on. And then it's graphing dots and list 1 and list 2. Actually, the dot plot, but it's using the box symbol. And so we'll go ahead and graph now. And there's our data, and there's our curve. And so we see the data. It's not a perfect fit. Some of the boxes are a little bit off of the curve, but it does look like a very strong fit. And so that means we must have typed all our data in correctly. Now we can actually use that equation to estimate if we wanted to predict. For example, this is giving us the this table is giving us the population of the United States in all of these years, and so we could use this to predict something like what was the population in 1875. So that would be 1875 would be in between these two, so we would type in 8.5. So on our calculator, we've got this graph, and if we one way to do that is with trace, and we want it right now. If you look up on the upper left-hand corner of the window, it says it's tracing on plot 1, and we don't want to trace on the plot, we want to trace on y1. So we hit the up arrow until that says y1, and now I type 8.5, and that tells me the population at that time would be about 44.6 million. So f of 8.5 is about 44.6 million. And that makes sense. That is a number that's in between 38 and 50. Okay, so now what I would like you to do is go ahead and try example B. And again, don't use this method from their table. You're going to go ahead and use these as your x values and these as your y values, and see if you can find the regression equation, the exponential regression equation for this data. So pause your video and try to repeat all those steps and come up with the regression equation, and then see if you can sketch a graph below. Okay, so the steps again to put in the data, and you can fast forward through this if you don't want to watch all of the steps. You can go to Stat, Edit, and then we want to clear the lists. So I highlight the title and I press Clear Enter. And I highlight the title and press Clear Enter. And so now I want to put in the X values in list 1 and the Y values in list 2. Okay, now that we have the data in there, we go to second, or not second, we just go to Stat. So Stat, Calc, and we're looking for option 0. So we can just type 0 to get to exponential regression. And I store the regression equation as y1. And then calculate. So it gives me a regression equation of y equals 86.2 times 0.58 raised to the x. And since I stored it as a regression equation, it's already there. We'll write that down here as our answer. Okay, so 86.177 times 0.5756 raised to the x power. And then we graph that. First, we'll set our window. For x values go from 0 to 9. So what I have there for x is fine. The y values go from, looks like our low is 0.6 and our high is 95. So we'll go 0 to 100. And then when I press graph, it shows me the data and the curve. And I could also sketch that here by plotting the points and drawing the curve. So for example, we would have 0, 95, and we would have 1, 55.9, and 2, 23.7, and so on and so on, and we get our exponential regression curve. Okay, if you go into page 707, this one for the years for x, let's just use the ones digit. So this would be x equals 2, 3, 4, 5, 6, 7, 8, 9, and 10. And go ahead and create your regression equation. And then after you have the regression equation, use it to predict what will the total catch be in the year 2017. So pause your video, work that out, and then press play when you're ready to check your solution. Okay, so I have all the data entered here, and so to create the regression equation, I'll go to Stat, Calc, Option 0. Oops. Let me try that again. Stat, Calc, and I'm going to scroll down until I get to Option 0, which is Exponential Regression. And then I'm going to store my regression equation as y1, so variables, y variables, function, y1, and calculate. So it tells me that the regression equation is about 2517.7 times b, which is 0.9174 to the x. Okay, and now we want to predict the catch in 2017. So that would be, if we wanted 2017, that would be when x is 17. So you could do this a couple of different ways. You could just type this expression into your calculator with 17 here. That'll give us an approximation. So we could say 2517.7 times 0.9174 raised to the 17th power. And that gives us a prediction of about 581 million tons of fish. So that's the prediction that our regression equation gives us by plugging in x equals 17. Another way to get this is from, I'll show you a couple of ways. You could, since we already have this function entered as y1 right here, back on our home screen, watch this. We can go second, or not second, we're just going to go vars. So variables, y variables, function y1 of 17. Enter. It tells us it's 581.1. Still very close to 581. That's the same answer we got from before, but this one's actually more accurate because it used all the decimal places, whereas we rounded our decimal places. Okay. A third way to get this is from the graph. So if I set my window to go from go from 2 to 10, so -5 to 15 will work fine. The y values in this table go from about 1,000 up to about 2,200. So I'll go 0 to 2,500. That one should be, we'll set that to 100, but the 0 to 2,500 for y min and y max. And then graph. There's our regression equation and our data. And then from that, we could press trace. And right now it's tracing the plot. So we up arrow until it's tracing curve y1 and type in 17, enter. Oh, it's off the screen. So we need to change our window so that it's on the screen. So before I can do this, I need to go to window and make my x values go up to 20. Now it'll let me trace. So trace, up arrow to get on y1, type in 17, enter, and now it does give me an answer of 581, same answer we got the other two methods. So the population in, or the total tons of fish caught in the year 17 is about 581 million tons. And that's it for today's lesson. Feel free to go back and watch those again if you're doing regression problems and you forget the steps. You can always go back and watch this again.